Yo, hello everyone. Welcome back to the channel. It has been quite a long time since I've recorded. Sorry, I've been pretty busy doing a lot of stuff recently. And today we're switching gears back to math, and today we're gonna learn about AOPS Intermediate Algebra Lesson 1.2. So, basically we're going to learn about something called substitution. Probably a lot of you probably already know what substitution is, like from 7th grade, but we're going to apply it to like more novel situations. And with that being said, let's get started. And substitution is basically the process of replacing a variable in an equation with another one, and it can be also used in countless aspects in math. Yeah, substitution is one of the best strategies. Like it's one of the basis, like it's one of the most basic strategies you have to have as a elite problem solver, unlike me. So yeah. And yeah, here's a quick example of substitution being used. Basically, you evaluate this if x equals to this random value. You basically, like, first of all, whenever there's an x, you replace it with a skeleton. It just makes things easier. And then you plug and chug the 5 into the skeleton, just like this, into the parentheses. Then you evaluate the expression with the x replaced of the 5. So evaluate this expression until you get your answer, which is 380. Yeah, I have checked online for the correct answer, and this is it. So, yeah, with that being said, let's just quickly get into the lesson. Okay, so the main part about today's goal is literally to solve these type of equation systems. So you may be wondering, what is even an equation system? Like, what are you even talking about? Well, as you guys can see, an equation system is basically composed of two variables and two equations, and that's called a two variable equation system, I think. So basically, you have these two variables, x and y. They have to satisfy these two equations as a whole, and you have to find certain x and y that meet this criteria. And we can use substitution a lot of the time just to solve for these two variable equations. So let me show you just in a sec. And for those who actually want to try this problem, please pause the video and try for yourself. But I'm moving on. And also, by the way, the hints also are very useful, but we're gonna see what the hints really mean in a bit. First of all, what I like to do when I even solve these problems is number them. This is 1, this is 2, and yeah, so we number them. It makes us like very easier to organize them, and also is like a pretty clear and organized method to just represent these equations other than just writing the whole lengthy equation down. And for the first one, remember how it says solve for x and y and substitute, I believe? Basically, what does it mean by solve for x? Move all the x terms on one side to one side and move all the y terms to the other side so that you only have x terms on the left side. So you're basically representing x, this variable, as some kind in some sort of relationship with y. In this case, it's just y plus 4. Well, this makes it very easy to substitute. As you guys have seen in the quick example, when x equals to 5, you can literally just plug that into the expression. We're trying to make that happen. But as you guys can also see, Y plus 4 is a little challenging than 5 for various reasons. Mainly it's because it's not just a term, it's an expression. But guys, you don't have to worry because you can literally visualize the y plus 4 over here as just like a single number. Like visualize this as a whole term, or how do I even call it? Just as a whole term and plug it in. It won't be that difficult. And yeah, my handwriting really sucks. So after we solve for x in terms of y, also you could just literally add y to both sides and it would just solve. So after doing that, let's try the substitution. So we have over here our newly found expression, and here is expression number 2. So how do we even, well, solve these equations? You see, we use substitution as literally said like 100 times before. Really, how you substitute is this. Let's say you have 2x plus y equals to 29. First of all, as before, you use the skeleton method by replacing the x with like parentheses. So, and then you plug in the y plus 4 in as a whole term inside the parentheses like this. And guys, remember the parentheses because you have to remember them. Like sometimes you need distributive property, and if you really don't remember the parentheses, they can cause a lot of order of operations errors. So yeah, please remember them. And then after that, we have this equation over here. We rearrange the terms by combining them or moving them over, and we get 3y equals to 21, and y equals to 7. And now that's equation number 4. Let's number it. So basically, now we have actually found the value of y, but you may be wondering, how about x? Well, this time we can do some substitution again. This time with 4 and 3. Basically, it is way easier to do just a single this substitution because it only requires this, like there's only one number. It's literally what you guys have done in 7th grade. So basically, you use the skeleton method as shown before. You plug in the 7, and over here you evaluate x to be 11. Well, that actually rhymes. Okay. So the ordered pair, or that's how we really write these solutions to uh these equation systems, becomes 11 7. So basically, do you guys remember how you guys used to plot like coordinate like points on the Cartesian plane or just on the coordinate plane? It's kind of like that, how you have to list x and y and with the parentheses and stuff. Yeah, this is basically the same thing, except you're not plotting the points. And with that being said, uh, let's move on to the next problem. Also, a quick note though, when you substitute anything into an equation, you have to make sure that the thing you substituted in is equal to the original like variable. Like for this instance, we have y plus 4, right? We already know that y equals to 7, so that's how we can safely substitute 7 in the replacement of y into this equation. And with that being said, let's move on to this equation. Sorry if it literally looks like so ugly like for some of you, because look at this. Like, how are you able to solve this equation? But we have a hint right here that I am very generously giving, so please look at it. So basically, you remember how you guys like remember how you do like 1/3 plus 1/2, how you have to actually find the common denominator, like the least common denominator inside the 2 and 3 to get 6, and then you multiply both sides of you multiply like both the numerator and denominator of some like number of these two fractions just to get 6, so that you can have the same denominator for the two fractions. So let's say 1/3 plus 1/2, right? For this one, you find that the common denominator is 6. So you just multiply by 2 on this side, so that the denominator is 6. And you multiply on 3 this side, so you also make sure the denominator is 6. You do that to the numerator so that it equals, and what you get is, well, 2/6 plus 3/6, which equals to 5/6. You can do the same for that expression, and there's also a bit of a trickiness to this problem that you guys probably haven't learned, but you'll learn in 8th grade. And that's something called factoring quadratics. But don't worry, as long as you get to the part where a quadratic expression, when a quadratic expression like literally pulls up. By the way, a quadratic expression is basically like, or equation is basically an equation with like an x squared term or y squared term. As long as you get to that step, you guys are good to go, and you guys already accomplished the mission of this problem. And you may solve this problem by pausing the video, but I'm going to move on, and let's just see how we even do this problem. So let's see, we can use our typical approach of substitution, but as you guys can see, number 2 really doesn't look like it looks like it's pretty grumpy, as you can tell. So we actually have to make sure to smoothen out the expression by using a common denominator approach. Well, this may not look that familiar, but this is just basically like a much more like it's the same thing, trust me. Except I just like literally multiply the common denominator out, which is actually easier. Because if you multiply the common denominator out, you don't have to find like really well, you don't have to find like what variable to multiply in order to get the common denominator whatsoever. You just do the multiplying. So over here, when you use the distributive property, this becomes y, as the x's cancel out. And then you do xy times 1 over y, where the y's cancel out. So you have y plus x equals to xy divided by 2. Yeah, you have to multiply xy to both sides of the equation to make sure they're equal. And now that looks a lot better. And as you guys see over here in the first equation, we just literally transform it by adding y to both sides, or simply just moving y over and flipping the sign to get that, and uh we substitute it into sorry, I meant this expression over here. Let's just say that's 2 for now. So we have this expression, right? We start off by again replacing all the x's in the equation by a parentheses, like what you would do when in 7th grade. And then you picture the y plus 3 as a whole number. So, and then you plug it in. Sorry, just for clarity, let's add those parentheses back here, even though it doesn't really matter in this case, but you have to be very careful with your order of operations. And over here, you guys can see that you have actually a squared term when you multiply things out using the distributive property. So as long as you have gotten something like this, you are good to go for today's mission. And well, for this problem. And then you multiply 2 to both sides just to get rid of this fraction. You do some rearranging and combining like terms to get this. And obviously, I don't think a lot of you really know how to solve quadratic expressions. So here's a video on how to factor quadratics. Here's a link. But probably I'm gonna like talk about factoring quadratics in like a more of like a special guest video, but it's definitely not gonna be today. So we factor our quadratics right here. Let's just pretend that magic occurred and that the expression rearranged itself into this. And then we can literally find x and we can find the two values of y. Because remember special case equations back in 7th grade where you guys learn how to solve like these expressions like y squared minus, let's say, 9 equals to 0. So basically, remember how you guys have like two like solutions, the plus and the minus? Well, you can kind of apply this to here because you also have to exclude oh my goodness, I can't speak. Two solutions and they're right over here. Yeah, so any quadratic would produce two solutions. Just keep that in mind. So then we can substitute this back to 1. Sorry if it gets a little crammed down here, but our approach is the same. We replace the y with parentheses, plug the 3 in, and we get x equals to 6. We do this for this, and we get x equals to 1. We do the same thing for y equals to -2. So writing these as ordered pairs, remember x comma y parentheses gives us 6, 3. Remember the x goes at the end, like after y, so you have to make that a little change. So that's 6, 3, and this is like 3 negative, no, this is 1 -2, sorry. And also note that x cannot equal to 0 and y cannot equal to 0 because remember how we had that nasty denominator situation at the beginning where we can't let x and y equal to, well, we had 1 over x and 1 over y. If we let those become, if we let x or y be 0, it would produce 0 as a denominator, and that is obviously false. And yes, according to mathematical definitions, so that's an extraneous solution. But luckily, we don't have to worry about that because nothing in our solutions states that x or y is equal to 0. And with that, let's move on to a slightly more challenging problem. This would probably make some of you go, ugh, I'll have to solve like a word problem. Yeah, I personally have that feeling when I really like do like these math problems. Like I have to solve them very quickly, and then they just suddenly a paragraph just bumps out. And yeah, they can be very confusing, the word problems. So the trickiest part during word problems is actually converting them to equations, and then it makes it 100% more clear of what you're trying to solve. We have some few like conditions for the problem though. So first of all, as you guys read the problem, we know that Jackie and Rachel, they each made this much. And we also know that Jackie worked 16 hours more than, Rachel worked 16 hours more than Jackie, but Rachel earned 2 less per hour. We have to, and finally, our last sentence, which is like the most important part, is what we're trying to solve. So you guys only have to solve for how many hours did Jackie work, nothing else. Or you could solve for like something else, but you could also substitute it in just to solve for how many hours did Jackie work. But remember to keep your eye on the ball. And you guys, with that being said, let's just look at how are the solutions. Well, again, you guys can quickly pause the video to solve it on your own, but I'm moving on as said before. And yeah, so what we do is that we let how many hours Jackie worked equal to X. If that really recalls some memories from 7th grade, how you had to solve word problems by using assigning variables, and then you guys have to draw a verbal model, and then you guys have to really substitute or just write an equation, and finally you have to solve it. This is what we're basically doing. So how many hours Jackie worked is shown over here as our verbal model, and we know that times this salary model equals to the total revenue. So that's basically our verbal model that we're setting up, and since we know no relationship between x, which is the number, which is how many hours he worked, and y, which is equal to his salary per hour, we can define two separate variables for these. So we substitute Jackie worked for X hours and he has a salary of Y per hour. And we know the total revenue that you remember how it said they made 960 each? So we know that X times Y should equal to 960. But obviously that is not enough just to solve for X and Y. There are infinitely many solutions in this equation. So we can use our relationship with Rachel over here as it says that she worked 60. Oh, sorry, I reversed these. So her wage is 2 less per hour, and she worked 16 hours more than Jackie. So basically, she has to work even more in order to get the same revenue as Jackie, and we can use that and represent that by x and y. So we know that, well, she worked 16 hours more, so that should be x plus 16. Remember, x is the work hours. And then her wage is $2 less per hour, so that's y. Y is the salary, y minus 2. And x plus 16 times y minus 2 equals to 960. And setting up this as an equation system will really get us over here. And again, we can organize our equations. So we have these two equations, and that's looking slightly a little similar to what we have done before. But look at expression number 2, and it doesn't look like the best, right? But remember how, like, the strategies we would use when we really, like, we would usually, like in this case, we would remember how we used to multiply by the common denominator last problem. Well, over here we can expand this expression. But how do you expand this expression, you may ask? Well, we just do something called FOIL. You multiply these two terms, x times y. You multiply these two terms, keep track of the signs, and then so you multiply these two, add these, multiply, and then you add this multiply, and then you add this multiply. Remember to keep track of the signs. And I'll really explain it like in more detail later, but rearranging this using FOIL would really give us this expression. And now we can just use substitution by dividing both sides of this equation by by y. So we get this. And then substituting it into 3 with this equation that we just rearranged. Remember, first do the parentheses, all of x, replace all of x with these parentheses, and then substitute 960 divided by y as a whole like term, and substitute it into these parentheses like this. And then when you multiply things out, you can start rearranging. For example, these cancel out, and this becomes a 1920. And then we rearrange these. Well, these two cancel out. You can subtract the 960 from both sides, and you have this. And I found out that you can divide by a common denominator of, as I believe, 16. No, not the common, just the common factor, like greatest common factor of 16. And we have this expression, and then we multiply the y out. And guys, we have our quadratic equation right over here. And please go check out that link in the that I sent, because you guys may not know how to do this. But if you guys get somewhere like close to having like an x squared, the y squared, and negative 2y, and like negative 120 or something, good job, as you have completely completed the mission of this problem. And then you solve for y, but again, you're trying to find x, because we let the work hours equal to x. So we substitute these two values inside to equation number 1, but we know that Jackie can work for negative salary right over here. Like, he can't work for like money. He can't work for a job that he has to pay money to work for. So there's only one solution after we substitute this thing in, and that is 80. So Jackie worked for 80 hours. That's our full solution. And now we can apply substitution into this small interesting problem. So I actually used a different approach than the one that's on the book to actually solve this type of problem. So basically, we're going to prove that these two expressions are equal. I mean, if these two expressions are equal, then this is satisfied. So how do we do that? Well, let's see. First of all, let's combine like terms. And so, yeah, because that's what we really do when we solve an equation. And when we combine the like terms over here, we have this. So we have, this is, let's say, our coefficient of the linear term, or just the x term. And this is our coefficients of the, well, just the constant, because we don't have an x. It's just a constant term. So there you go, guys. We know the right side is equal to 0. How can we literally use that? So we can rewrite the right side as 0x plus 0. Remember, anything times 0 is equal to 0. So the coefficients of x on the right side should equal to 0. Basically, a minus c and b minus d should equal to 0, because we know that these two are equal, right? This one and these two are equal. So we basically have to make the right side 0, x plus 0. So you can make a minus c equal to 0, and that's 0x plus 0, or b minus d equals to 0, and then you get this expression. So yeah, that should be applied to the constant terms as well, as we know the constant term over here is also 0. Or you could think of it like you have to substitute the linear and constant terms with 0 to make the expression equal. And after you make the expression equal, then that means that, well, a minus c has to equal to 0, and b minus d has to equal to 0 as well. Because that, or else the expression wouldn't be equal. In order to make that substitution process work, remember, you have to replace the original value by a variable by a value that you know equals to the original value. We can use this property to literally write out this equation system, and rearranging by adding c and d to both sides gives us yields a equals to c and b equals to d, as proven. And with that being said, I shall present to you your homework. Just kidding. It's totally optional. It's just for those who really like doing math problems. So yeah, these are some math problems that I have presented to you. They also are somewhat challenging, as you guys can see, but because for you to solve problems. So, with that being said, goodbye, everybody, and have a great day.